To everyone, welcome to my channel. Apiwe Damboza is with you, and today I will be busy delivering a lesson taken from equation paper June examination paper 2 2022. This is question 4. It reads as follows. In the diagram below, the coordinates of A, C, and B are the vertices of a triangle in a quadrant plane. So we are told that CE, which is CE, is perpendicular to line AB, which is this line AB. CE is perpendicular to it, and with E on AB, this is AB, then there's E on AB, and E is the midpoint of a straight line CD. So this is the midpoint of straight line CD. That makes CE being equal to ED. So that's the information that we have so far. Then what are we having? Determine the gradient of AB. Gradient of AB, when you have 2 points in a straight line, you can just use the formula to calculate the gradient. So the gradient of AB is given by y2 minus y1 divided by x2 minus x1. So on that note, we just always need to remember that the gradient of a line is change in y divided by change in x. Otherwise, when you do it the other way around, you will get it wrong. Now, what are we having? We have y1 and y2 and x1 and x2 that we need to substitute into our formula. So let's say y1 is going to be, y2 is going to be 5, then 5 minus 1, then divided by x2 is going to be negative 4, then x1 is going to be just 4. So negative 4 there also. So what are we having now? We have 5 minus 1. 5 minus 1 is 4. Then minus 4 minus 4 is minus 8. Then the simplified answer is just negative half. So the gradient of AB is negative half. And we expected this gradient to be negative because you can see that the line is going down as you move to the right hand side. Now, after finding the gradient of AB, we can now be mindful of calculating the equation of CD, which is the second question. So the equation of CD, we know that the equation of a straight line is given by y is equal to mx plus c. For completion of equation of a straight line, we need a gradient and we also need a value c. So how do we find the gradient of this line now? You will remember that this line CD is perpendicular to the line AB. So which means that is the line. So what do we know about perpendicular lines is that the product of their gradients give you negative 1. So what that means, if the gradient of AB is negative half, then the gradient of CD is going to be just positive 2. So the gradient of CD is going to be just positive 2, because positive 2 times negative half will give you negative 1. So that is why the gradient of CD is just positive 2. Then therefore we can continue using our formula. In the place of m we put 2, then we have x, then plus c. Then therefore finding c, we can use the coordinates of c there, because this is the only point that we know in the line CD. Now, in the place of y, we can just put negative 4. Then in the place of x, then we can just put negative 1, just like that. Then this is plus c. Then after that, we can just proceed. Then therefore we have minus 4 plus 2, which is just going to be negative 2. Then after that, people used to forget to complete now the equation after befumene uc. They used to forget to plug into the formula to complete the equation that is required. So we have y is equal to 2x then minus 2. This is the one now what the equation of a line CD. Completed. Lovely. Now coming to the next question, we are to determine the coordinates of C. Coordinates of C, you can see that it's 6 marks, which is there's a lot to do. Now let's go back to our diagram. Our diagram, we have this kind of situation. E is said to be the midpoint of this CD, but since we don't have D, so we hardly use the midpoint formula. Otherwise, if we had the coordinates of D, it would be easy. We would just use the midpoint theorem to determine the midpoint E, which is the midpoint of CD. But because we don't have D, now we need to figure out another way of finding the coordinates of E. Now, if you will remember that at this point, this line and this line, they intersect each other at E, which means they are equal. The equations of these two lines, they are equal at E, then therefore we can just equate them to solve the values of x, or the value of x. Now that makes equation of AB being equal to the equation of CD at point E. So we need to apply this method now. You will remember that we have already figured out the equation of CD. We are left to find the equation of AB now. But half of something is already done, that we do have the gradient of AB already, that it is negative half. Then therefore the equation of AB is equal to negative half x then plus C. Then therefore finding the the value C, we have to use one of these coordinates. We either use the coordinates of B or the coordinates of A, but we cannot use C because C is not on the line AB. So we have to use, let's just use 4:1. In the place of Y, let's just use 1. Then the place of X, we just gonna be putting 4, then therefore plus C. Then therefore we can simplify, then we have this, cancel that, we left with 2 there, which is negative 2. Then our C becomes 1 plus 2, which is just 3. So we can now see that the equation of AB is now equal to negative 1 over 2x then plus 3. Now we have both equations, the equation of CD and the equation of AB, and we know that these two equations, they are equal at point E. Now that is why we'll have to equate their equations to solve the coordinates of E. Now what are we having? We are going to use this information to say the equation of AB. The equation of AB is negative 1 over 2, then x plus 3, then which is equal to the equation of CD, which is this one, then which is equal to 2x minus 2. Then therefore, trying to simplify, we can just multiply by 2 both sides through all the terms, which is gonna be negative x, then plus 6, then is equal to 4x, then minus 4. Then after that, we can just take this x to the other side to get 5. Then we have 5x. Then we take this negative 4 to this side. Then we get 10. Then we end up having x being equal to 2. Now, after having x being equal to 2, we can take our y, which is equal to 2x minus 2, and substitute in the place of x, we put 2 there. Then therefore to find the y coordinate of E, which is also 2. Now the coordinates of E is just x is equal to 2, then y is also equal to 2. So the idea was to equate the equations, the equation of AB and the equation of CD, because at E these equations or these lines are equal to each other. Then moving to the next question. The next question, it requires us to determine the coordinates of D. Remember that the coordinates of E are already given or are already proved or found by us, that now we have to use this information to calculate what is x2 and y2, if this one is x1 and y1. Now the midpoint theorem, if we have the midpoint, we can just break it down to say we have the midpoint, x coordinate of the midpoint, which is given by x1 plus x2, then divided by 2. Then therefore we have a y coordinate of the midpoint, which can be given as y1 plus y2, then divided by 2. So this is how we use the midpoint formula when the midpoint is there, so which is not a big deal anymore. So the x coordinate of the midpoint is 2, then we have 2 then is equal to, then we have, let's say x1 is -1, we have -1 plus x2 is not yet found, then divided by 2, then y coordinate of the midpoint, which is this one, 2 of course, then is equal to, then y1 is -4, then plus y2, we don't know because y2 is the y value of D, then divided by 2. Then trying to simplify this one out, then we'll be having 4, which is equal to -1 plus x2. Then this one will be having 4 also, which is equal to -4 plus y2. Then therefore our x will be equal to just 5. Then our y2 will, okay, x2, our y2 will become just 8. So the coordinates of D in this case is going to be 5 is to 8. Now that is what we have. Now moving to the next question. We are having, let me just rub off everything else that we might not need. You can always go back to check the information that I rubbed if you need one. Then the coordinates of D, I can just rub these ones. The coordinates of D is 5 is to 8. Good. Now determine the equation of the straight line passing through point D and parallel to AC. So now this equation of the line is passing through D and parallel to AC. This line that we have has to be parallel to AC, just like that, so that these lines, they share the common gradient, because once the lines become parallel, the gradients of those lines is the same. Now that means we will need the gradient of AC. The gradient of AC we can just quickly find it out, that we have 5 plus 4, then divided by -4 plus 1. That makes it to be, what are we having? This is 5 plus 4, then divided by -4 plus 1. That makes it 9 over -3, which is going to be negative -3. So the equation of the gradient of AC is -3. That makes the equation of this line that you are looking for, which is this equation, is going to be -3x. then plus c. Then how do we determine the value c? We're going to use a point where this straight line is passing through it, and we are going to use the point D. Now the point D, we have 8 in the place of y, then we have 5 in the place of x, then the 4 plus c, then our c, we have 15, then 8 plus 15, which is just equal to 23. Then therefore we have y is equal to negative 3x plus 23. So that is the equation of this straight line, which is passing through D and parallel to AC, because the gradient of AC was really needed for us to find the gradient of this new line. So that is what we have for question number 4. Let's quickly go to question number 5. Question number 4. Question number 4, which is the last question. Now, question number 4 says 4.6, determine by showing all calculations whether the x-intercept of the straight line CD, remember the equation of CD was determined to be 2x minus 2, also lies on the altitude, which is the perpendicular height from A to BC. From A to BC, which means this perpendicular height from A to BC. You are determining whether these two lines as the same x-intercept. They looks like they do have the same x-intercept, but we need to figure it out by showing calculations. Now, our calculations will be shown by first finding out the x-intercept of CD. X-intercept is where y is equal to 0. Then you have 2x minus 2. Then your x becomes just 1. Then we have found the x-intercept of CD. Now we need to prove using a specific method that also the line A, let's just have F here, the line AF also pass through that same x value. If it doesn't, then therefore we have proven the other way. Now we need to calculate now the equation of this line AF. The equation of line AF, and unfortunately we haven't found the gradient of BC. We'll need the gradient of what? Of BC. The gradient of BC is given by, we have 1 minus 4, which is plus 4. Then therefore we also have 4 minus 1, which is just that. Then therefore the gradient of BC is just 5 over 5, which is just 1. Now, what are we having? We have y is equal to then x plus c. Then therefore the gradient, the value of c can be found using the value, the points of A, because this is the line that this is the only point that we have in line AF. Now the point A, y is 5 there, then x is negative 4, x is negative 4. Then what are we having? Then plus c. For now, this is what we have. Then we have this kind of situation. For now, what are we having? First of all, let's first find the gradient of BC. The gradient of BC is that, which means the equation of AF, now, the gradient of it is going to be negative 1. is going to be -1, remember, because this line is perpendicular to BC, of course. So we are going to be having -1 if the gradient of BC is 1, then therefore the gradient of AF is -1. So we have that kind of situation now. So we now can substitute by using these values of A. In the place of y we put 5, then in the place of x we put -4. That makes negative, then therefore is equal to C. Then our C becomes just 1, because we have 5 minus 4, which is just 1. So the equation of line AF or FA is equal to -x plus 1. So let's continue finding the x-intercept now, because we are interested in finding the x-intercepts of these two lines, whether they have the same x-intercept or what. Now, in the place of y, we put 0, then we have -x, then plus 1, then we have -1 is equal to -x, then x is equal to just 1. Then this is just what we have. Then therefore you can see that both of them, they have the same x-intercept right there. So really, they are intersecting at this very same x-intercept, which is x is equal to 1. So this is by proof that they have the same x-intercept. I think it concludes question number 4.6. Yeah, how it goes. Now coming to the next question, which is question number 5. Well, now what are we having? We have in the diagram below, M is the center or is the common center of two circles. The larger circle has the equation that the smaller circle touches the straight line this at point A. The straight line y is equal to 0 cuts both circles, which means it cuts both circles somewhere. So this is the information that we have so far. Now, the question that we have, it's determine the coordinates of M. When the equation is given, it's always easy to determine the coordinates of the center. Now, taking our equation down just like that, let me just drop this thing up. We have x squared, then plus y squared, then minus 4y, then plus 2x, then is equal to 44. So we have that for now. Then let's complete the square. We usually take things to close to each other, those things that are having similar characteristics. Then therefore what we do, we just open this squared, then plus, we say y, then squared is equal to 44, that one. Then what we do now, we are going to write half of this. Okay, we have plus here and here we have minus. Then we always write half of this number, which is the coefficient of x, right there. And here we always write the half of this number, which is coefficient of y, which is 4 there. Then half of 4 is just 2. So this is what we have. But on the other side, whatever that we wrote up, we'll always add the square of those numbers on the right hand side. So this is what we have. Then the answer on that side is just gonna be 49. Yes, that is 49. Yeah. So when you have the equation of the circle in this format, it's always easy to take down the coordinates of the center. So the M coordinate is gonna be, if you have +1 here, you always write the opposite sign. Then if you have -2 here, you always write the opposite sign. So the coordinates of M is -1 is to 2. Lovely. Moving to the next question. The next question says, determine the coordinates of A. Remember, the coordinates of M is -1 is to 2. Now they ask us to determine the coordinates of A, which is this point. Now, what do we know? We understand we are having this, which is the radius, and this line there is a tangent of the circle, and at A, the radius of the circle and the tangent, they are equal there, they are intersecting. So the idea now is to look for the equation of the tangent of the radius, I believe. So what are we having? The gradient of MA or AM is equal to is gonna be equal to 1. Why? Because the radius and the tangent, they are always perpendicular at the point of intersection. And now the gradient of the tangent is equal to -1. As you can see that this line given there is the equation of this tangent now, and the gradient is -1, as you can see there. That makes the gradient of the normal line to be -1, because once they are perpendicular to each other, their product has to give us -1. So that is why we now have the gradient of AM being equal to just 1, because 1 times -1, they give us just -1. Perpendicularity theorem. Now, after having the gradient of AM, we are looking now for the equation of AM itself. Then therefore it's going to be 1x plus c. Then remember that we do have the coordinates of M that we are going to use them, which is in the place of y, we're going to put the y coordinate. Then in the place of x, we put the x coordinate. Then therefore plus c. Then therefore our c becomes just 3. That makes the equation of AM to be just x plus 3. We are not done. The idea is to find the coordinates of A, and we said in order for us to find the coordinates of A, this is where these two lines intersect. Then therefore we are going to equate their equations. Now, after understanding that the equation of the tangent is equal to the equation of the normal line, which is of the radius at A, then we are going to equate these equations. So we are going to equate this equation and this equation. So what are we having? We have -x plus 5, which is the equation of the tangent, is equal to x plus 3, which is the equation of the radius. Then therefore after that, we just take this x to this side, then we have 2x, then we take this 3 to the other side, then we have just 8. Then therefore our x becomes just 4. Wow. After that, we can use any of these equations, which is y is equal to, let's use this one in the place of x. We put 4, then plus 3, plus 3. Then therefore what we get 7 as the value of y. Then therefore what we have, yeah, so the equation of AM is that, then therefore plus 3, yes, then this is what we have. Then after finding the, yeah, so no, this is the a big mistake that we have made. When you take this 3 to the other side, it doesn't becomes 8, it becomes 2. Remember, it becomes 2 because 5 minus 3 becomes just 2. Then our x becomes just 1. Yeah, yes, got it. Now after that, we are going to find the y value by taking this, and in the place of x you put 1 in the place, yes, then this is what we have. Then y becomes just 4. So now the coordinates of what? The coordinates of a is x is 1, then y is just 4. So we have figured out that coordinates of a is 1, is 2, is to 4. We are done. For that one, the idea was to find both equations, which is the equation of the f of am was to be found. Otherwise, the equation of the tangent was given. So we had to understand that at point A, these equations are equal to each other. So that is why we have calculated the equation of MA, so that we equate it to the equation of the tangent, because at the point A, these two equations has to be equal to each other. Now, let's go to the next question. Going to the next question, the perimeters are already here. We have -1 is to 2. Then here we have 1 is to 4. Yeah. So another question, which is 5.3, it says determine the equation of the smaller circle. Equation of the smaller circle. Remember this, the smaller circle, we do have the center of it as well. Then therefore we just need to remember the format of the equation of the circle, which is x minus a, then put squared, then plus, then y minus b, then you put squared, then is equal to r squared. So what we need to remember is that the value of a and b are the x and y coordinate of the center respectively. Now, we do have the coordinates of a, the value of b as well, because this is -1 is to 2 respectively, and these values, this x and y, are any points on the circumference of the circle that you are looking its equation. Now, what are we having? In the place of x, we can just use the coordinates of a, which is going to be 1 in the place of x. Then therefore the value of a is -1, then we end up having just 1 there. Then therefore plus, then y is going to be the y value of any point on the circumference of the circle, then which is 4 in this case, then minus, then b becomes just 2, then therefore we have 4 minus 2, then all squared. The idea is to look for r squared. So r squared here, what are we having? We have what? We have 2 plus 2 squared is equal to 4. Then therefore we also have another 2 squared, which is equal to 4. Then our r squared is equal to just 8. So this is what we have. So on that note, the equation of this circle will be given by x plus 1 squared, then plus, then we have y minus 2 squared is equal to 8, because r squared is given by 8. Yeah, so this is what we have. Done with finding the equation of the smaller circle. Moving to this question, which is the question 4, 5.4. Calculate the coordinates of k. Coordinates of k, you will see that it is the y-intercept. It's an x-intercept of the tangent of this circle, which is, now we do have the equation of it, which is -x plus 5. That now you need to remember that in the x-intercept, y is equal to 0. Then therefore we have -x plus 5. Then therefore we can just continue to figure out what is the value of x. The value of x is 5. Then therefore we can now write down the coordinates of k, which is just 5 is to 0. Now we are done with that one. That's just 1 mark. Moving to the next question. The next question is question number 5.5. 5.5 says the straight line this meets the straight line y is equal to 0 at point k. Yes, this is what we know. Determine the area of triangle AMK. The area of triangle AMK, which is this line, and we know that this is a right angled triangle. You will remember that we calculated the what, the equation of the small circle, that we got r squared being equal to 8. Yes. Now, which means r is equal to root 8, which is now this distance is just root 8. Good. Now, we know that to find the area of this kind of triangle, we need this AM that we got already. Then AK, we need to figure out what is the length of AK. But you just remember that the coordinates of K is 5:0, and the coordinates of A is just 1:4. Then we can just use the distance formula to calculate AK. AK is equal to, then we have x1, which is 1 minus 5, then squared, then plus, then we have 4 minus 0 squared. Then therefore, what are we having? We have 4 squared is 16, another 4 squared, which is just root 32, the root 32 units. So which means AK, this distance is root 32 units. So on that note, to calculate the area of triangle AMK is given by half. Base is AK, we can just put root 32 times height, which is root 8, which is AM, which is root 8. And you can see that we are having, if you press your calculator, you will get just 8 units squared. So this is the area of this triangle AMK. So done with that. Then let's check if we still have another thing to deal with. Wow. Question number 6. Question number 6 is trick questions that are so simple to understand, and you can score minimax here because few things are to be taken into consideration, and at the end of the day you just need to be very careful when it comes to Pythagoras theorem and how do we use the diagrams to solve this problem, because in most cases calculator is not permitted. Now, what are we having? We are having cos 26 is equal to 1 over p. Then you are asked to determine the following in terms of p, which means your answer must be in terms of p. There must be p in your answer. Now let's come to this one. What are we having? If you have cos 26 is equal to 1 over p, you just need to remember so ka to wa. So ka is so ka to wa. So we need to remember this SOHCAHTOA, that if you have cos 26 is equal to 1 over p, this is the adjacent and this is the hypotenuse. So which means cos 26, if you have 26 here, just have your rough diagram. Then we know 26 upper, we know 90 upper. Then here you have to have 64. This is going to be 64. Now, you have to fill in your diagram that you have cos 26 is equal to, this is the adjacent side, which is 1 over hypotenuse, which is p. So of course you are going to look for this side, and this side we can just call it y. Then y squared is equal to then p squared. then minus 1 squared, and then our y becomes just what? Square root p squared minus 1 squared. Yeah, that is just it. Now this is what we have. So this side on its own is given by p squared minus just 1. So this is what we have for now. Now let's come to 6.1.1. 6.1.1 says determine sine 26. Sine 26, you'll remember that sine is always opposite over hypotenuse. So it's opposite over hypotenuse. That makes opposite side to be root p squared minus 1, then over hypotenuse, which is over p. So that is sine 26 in terms of p. Then coming to cos 52. Cos 52, you will remember that 52 is not found in our diagram, but 52 can be made by these special angles that we have in our diagram. For example, now we have cos 52 that can be broken down to be 2 times 26, and you will see now that you have a double angle. So remember that the double angles, of course, is cos 2 2 cos squared 26, then minus 1. Then the other one is 1 minus 2 sine squared 26. The other one is cos squared 26, then minus sine squared 26. So you can take any of these to substitute, but you can always take the easiest one to make things easy for yourself. Now what are we having? We have 2 then times what is cos 26. Cos 26 was given by 1 over p. Then in the place of cos 26 you can just put 1 over p, but remember that this cos 26 is now being squared, then minus 1. Then simplifying this, you have 2 times 1 over p squared, then minus 1. Then your answer can always be simplified by just like that. So this is what we have now for cos 52. Remember that we broke down this 52 to be 26 times 2 to take us straight to a double angle, of course. Yeah. Now let's come to number 3, but I think we can always come back for the rest. Let's just make things clear for this one, so that we have a clear space. Yeah, so having this one, let's take this tan 64 squared, then times p plus 1. Now let's go to our diagram. In our diagram, we always remember our SOHCAHTOA, that tan is always opposite over adjacent. So we use our SOHCAHTOA. So tan is opposite over adjacent. So that now tan 64 is opposite over adjacent. So which means opposite side over adjacent side. So that makes 1 over the adjacent side is just what? Root p squared minus 1. But let's remember that this is being squared, then therefore there is a multiplication of p plus 1. So this is what we have. So we can always make things simpler. Now what are we having? We have 1 over p squared minus 1. Yeah, because this, when you square this one, the square root goes away, then you'll be left with the discriminant. Now this is what we have, then times p plus 1. But you can see that it's not simple because the denominator can be factorized. So let's factorize the denominator over there. Then we have p minus 1, then plus p times p plus 1, then times p plus 1, that one that was given there. Then therefore you can always see that these ones cancel each other, then your final answer becomes just p minus 1. So just like that. I think this is the simplified one for 6.1.3. Let's go to the next question if we have any. Well, we are having this 6.2. 6.2 is clear and straightforward. Here you are simplifying. Simplifying this expression will require us to remember the reduction formulas and everything else, and some identities, of course. Now, what are we having here? We have sine negative beta, sine negative angle, negative beta. People used to be confused when they are dealing with the negative angles. What I usually advise them is to always change the negative angle to a positive angle. How do you do that? When you are having, like for example, negative b, if you can just add 360, you are not changing the quadrant or the point where this streak is found. You are just changing the nature of the angle, not the quadrant, because we know that the revolution on its own is equal to 360. So when you add 360, if your point is right here, when you add 360, that means you move in an anti-clockwise direction right back to the very same point. So you are really not changing the quadrant, but to change how the angle looks like, né? So on that note, I usually advise learners to always add 360 so that they judge the quadrant that they are focusing on. So for example, here we have 360 minus beta. 360 minus is found on the fourth quadrant. So it's where sine is negative, and we are going to just write negative sign there. So which means this one is just what? Negative sine beta. So you get a mark by changing this thing. Then coming to the second one, we have 360 minus beta. 360 minus beta is also found on the what? On the fourth quadrant, where sine is negative. So you will be having negative sine beta again. Then all divided by. Then 180 minus beta, we know that 180 minus is found on the second quadrant where sine is positive. Then we can always have just sine beta. Then therefore plus, then sine 180 is of course equal to 0. So we can always simplify our expression by saying, okay, what is minus b sine beta minus sine beta? It's just minus sine 2 beta, then divided by sine beta, then plus 0. Yeah, doesn't make any difference. Then therefore we can always cross these things. Then therefore the answer is just negative 2. So for 5 marks, you just done yourself a good job. Now let's come to the next question. Let me check, what is it? Wow, yeah, here they say determine the value of p, then correct to 2 decimal places if theta is equal to 82, and this expression is equal to this expression on the other side. So here you are being tested the skill for substitution, and how do you go about using your algebra in trigonometry. Now here you are going to be just taking let's just have 2p, then tan, then in the place of theta you can just immediately substitute by just 82, then divided by 2, then is equal to, then we have sine 2 times 82. So on that note, we can always divide by what we don't want, and we don't want 2 and this one. We just want P, then therefore let's just destroy what we don't want, but we destroy it procedurally. We divide by it both sides. So we're gonna divide by 2, then turn, let's just simplify this. 82 divided by 2 is just gonna be 41. Then we also divide by the same thing on the other side, so that this one cancel this one and this whole thing cancel that one. Then therefore we are just gonna be left with P on this side, then is equal to, then on the other side we just need to press wisely our calculator. Then we have 2 times 82, then divided by 2 times 10 41. Then this is what we have. So the answer that we get is having so many decimals, but let's just remember that we are rounding it off to 2 decimal places. Having 0,15854222353, we can just say we have 0,1, then therefore we have 58, then it's gonna be just gonna be 0,16. So this is just what we have. We have solved. The value of P3 marks was just for grab. Now that is what we have, and let me just clear it up. I hope you have taken it up, and you can always come back to check if there's something missing. Now let's come to this one, and they say prove the identity, and this is this whole thing. It must be equal to that small one, and of course it is wise to simplify than complicate. So it's not easy to start with the right hand side. We can always simplify, take the complicated one to make it simple. Yeah, so on that note, let me just take this 4 sine theta times cos 3 theta, then minus 4 cos theta times sine 3 theta. So we are just taking the left hand side to check what are we going to get. Now on that note, we can see that we have 2 terms here. We have this term and that term. So what do you notice? I notice that in these 2 terms there is 4, then 4 is common, and what else that is common? Sine is also common. Then what else that is common? We have cos, and cos is common. So probably everything else is gonna be common, then therefore we see what's gonna remain behind. So taking the common factor, let me just use this one. I'm having 4 sine theta cos theta. So this is the common factor that I've taken out. Then after that, 4 is out, then sine is out, then we'll be left with just cos squared theta here. Then therefore minus, then 4 cos sine is out, then you'll be left with just sine squared theta here. Then after that, you will remember that we have 4 sine theta, then cos theta, which is times, then this one, you'll remember that this whole thing is just the double angle of cos, that we are going to write it just cos 2 theta. Now this one, you will remember that there's something that is communicating with us, that we can just break this 4 to be 2 times 2, just like 2 times 2, then sine theta cos theta, then we also have this cos 2 theta here. Now what do you notice? This one on its own, is the double angle of sine. 2 sine theta cos theta is the double angle of sine, so that we can just squeeze it up to say, we are having 2 times this one is the same as 2 sine 2 theta, okay, then times this cos 2 theta. So having this one, we can see that this is also the double angle of sine, because now we know that the double angle of sine, we have 2 sine an angle cos of an angle is equal to 2 sine 2 of that angle. So which means this is the angle that we're talking about now, and we have 2 sine angle cos angle is the double angle of sine. So that makes us to have sine 2 of this angle. Then therefore we can just simplify to say we have sine, what is 2 times 2 is just 4, then theta. So you can see that now the left hand side is equal to the right hand side, just like that. Okay, now moving to the next question. The next question is question number 7. Question number 7, we are having the f at x is equal to sine x minus 13, then g at x is equal to cos 3x. So on that note, let's just have the question. The question says solve for x. If we have this being equal to this for x, which is an element of what, of from -60 to 180. Now, how do we go about solving this one? What are we having? Let's just write it down first. Let me just use this different one. We have cos 3x is equal to sine x minus 30. Then this is what we have. So the idea here is to first make the trig ratios to be the same. For example, if you are having sine 30 here, it must be equal to sine what? If the trig ratios are equal, the angles must also be equal to each other for the left hand side to be equal to the right hand side. So this is the idea that we need to do. We need to, if we have cos this side, we need to have cos on the other side as well, so that if we have x here, we need to also have x that side, so that cos x being equal to cos x. Common sense, that is applicable. Now let's come and apply this concept here. How do we then change sine to be in terms of cos? Because the idea is to change one trig ratio to the other trig ratio. We either change cos to be sine or sine to be cos. It depends on which one that you want to work with. Now we just need to remember these core ratios, that if you have sine x, it is also equal to cos the 90 minus the same angle, which is x. That makes sine 30 to be equal to cos 90 minus the very same angle, that one. So this is gonna be cos 60. So that makes core functions, core ratios, that if the angles add up to 90, that 30 plus 60 give us 90, and the trig ratios are different, then therefore these trig ratios are going to be equal to each other. Now let's now apply this idea of co-ratios so that we change these trig ratios to be equal on either side of the equation. Now, what are we having? We have cos x 3x is equal to, we are changing this right hand side so that it is also going to be in terms of cos. So on that note, we are going to change this sign to be cos, but remember we're going to have 90 minus the very same angle. The angle is x minus 30. So this is what we have. So wow, we have cos, we have cos. Now we are on the go. Now let's just try to simplify some few things here. Then we have cos there, then therefore 90 plus 30, because 90 negative times negative becomes positive, so we can say 90 plus 30, then you will end up having just 120. It's going to be 120 minus x. So this is what we have. So at least now we have something is being done, by us, and we are so proud about ourselves. Now, the idea now is to apply that information that if the ratios are already the same, the angles must also be the same. So on that note, we are going to equate the angles, just get rid of the trig ratios because they are already the same. Now, what are we having? We have 3x is equal to just 120 minus x. But then let's now remember that we are going to add 360 immediately when we get rid of the trig ratios, because now we are already doing something which is going to put an effect to our calculations. No, now what are we having? 360 k, where k is an element of integers. Now, when you are adding 360, you just need to remember that that step is on its own is going to give you a reference angle. So we are going to use this as a reference angle. So now we can continue calculating, but at the end of the day, when we're looking for another general formula or general solution into the other quadrant, we're going to use this reference angle. Now let's just quickly answer. Let's take this negative to the other side. Then we're going to be having 4x is equal to 120, then plus 360k. Then therefore we have x being equal to, what is 120 divided by 4? 120 divided by 4 is just 30. Then plus even that 360 it has to be divided by 4. Then therefore on that note we're gonna be having 90. Then it's gonna be 90k. So this is our first general solution. Then continuing to find the second general solution. The second general solution for cos, it's where cos is also positive. So we can just say our reference angle, which is 3x is equal to, then we get into fourth quadrant, that we are going to say 360, because we are dealing with cos. Where else cos is positive? At fourth quadrant. Fourth quadrant, what is the reduction formula of it? It's 360 minus a reference angle. So 360 minus 120 minus x. Then you are subtracting this thing now. Then therefore let's not forget to say plus 360k as well. Then therefore we can now continue answering or just trying to simplify. Then we have 360 minus 120, which is just going to be 240, then plus x. Remember, this negative and this negative becomes just positive. Then therefore we can just take this x to the other side, so that we just have 2x is equal to 240, and then plus 360k, where k is an element of real numbers of integers, I'm sorry. Then this is what we have. So looking for c, for x, we divide this. So 240 divided by 2 is just always going to be 120. Then plus, then what is 360 divided by 2 is just going to be 180. So this is what we have. So we want now to find the actual values of x, because these are just general solutions. We want to find the actual values of x, where we are going to use this k now. This k is going to be used now to substitute in the place of k, where k is an element of integers. You can just start from -2, then -1, then 0, then 1, then 2, then 3, then 4. So these are the values that are possible to be used to find these actual values that are found in this interval that is given. So we are going to use our general solutions to find the actual values of x, that are within this interval given over there. So if we use this one, then in the place of k, we're gonna put we have 30, then times 30 plus 90 times, let's just put -1. When you put -1, you get negative 60 as the first angle. Then when we put 0, we get 30. Of course, when you put 0 here, we're going to get 90 times 0 is 0. Then 0 plus 30 is going to be 30. Then another one, when you put 1, you get 120. Okay. Then on that note, you may not have done, you can just come to this one also and substitute. What are we having? We have 120, then plus 180 times, let's just say -1. When you say -1, you get the very same angle, which is negative 60. When you put 0, you get the same angle, which is 20. So which means you can see that it's only this general solution that helped us to find these three values of x in this interval, because now other values, they are beyond, not that they don't give us the correct answer, but they are giving us the correct answers that are beyond the given interval. That is why we do not consider them now, because we are being guided, by the way. So let's check the graph. I will come back for the graph because I really need a grid paper or a grid diagram to actually try to be more precise in terms of sketching and stuff like that, because 7.3 will require us to use our graph to answer. So I will come back for 7.2 and of course 7.3. Let's come to this question number 8. Question number 8 is not that much simpler or easier. You just need to write your things, then done. Then you move to the next one. Then to this one, the statement is given that refer to the figure shown below. PQRS forms a straight line road with TQ, another road that is perpendicular to the road PQRS. Now, which means we are having this as a road, and this is another road which is perpendicular to that road PQRS. I believe this is the main road, and this one is going home. Now, the distance RS is equal to d kilometers. So the distance RS is equal to d kilometers. This is what is given there. Then T1, where is T1? T1 and T3 are equal to each other, and they are equal to alpha. That is information that is given. Then QTS, which is this angle, is equal to beta. This angle as the whole is equal to beta. So the first question asks us to write down the size of QTR, which is this angle. What is this angle? If this whole angle is beta and this angle is theta, then therefore this one is gonna be beta minus theta, which means it's gonna be this one minus this one. So this is just beta minus alpha. So on that note, we are just having beta minus alpha for the answer for 8.1. Then 8.2, they are specifying the triangle to look at SQT. In triangle SQT, we are going to determine the size of S. So this one, and remember that this is 90, and this one on its own is beta, and this one has to be 90 minus beta. This one has to be 90 minus beta, because yeah, that is what we have. So this one is what is 90 minus beta. So coming to another triangle that is being specified, PQT is in a triangle PQT. Write down the size of P. The size of P there, what you notice, we notice that if this is alpha and this is 90 and this and this one is going to be 90 minus alpha. So this one is going to be 90 minus alpha. Okay, now coming to 8.4, determine the length of TR or RT in terms of alpha and beta. So we are determining this length of TR in terms of alpha and beta. So what do we do? Yeah, when you are having diagrams like this, just remember the rules: sine rule, cosine rule, and area rule, and stuff like that. So on that note, we are going to use one of those rules. So having TR, we do have TR, we have RS, we also have this angle, we also have this angle. So we can just simply use in what you call sine rule there. So now our sine rule will be TR over the side, the angle that is facing that TR, and side angle S is equal to, remember we solved it here, divided by sine then 90 minus beta is equal to, what are we having next? We have this angle is given and this side is given. So what are we going to be having? We have D divided by sine alpha. So this is what we have. Now, what are we having next? We are going to solve TR is equal to then D. But remember that sine 90 minus beta is the same as just cos beta from co-functions or co-ratios. So this one is going to multiply that D there, but it's a multiplier saying cos beta, then divided by sine alpha. So our TR is given by that. Now that makes things to be easier for us. Then TR, let me just take it down over here, divided by sine alpha. Let's come to the next question. The next question says hence or otherwise determine, oh, let me just, can I just take this one to this? Yeah, can I just take this one to, okay. Okay, yeah, okay, good. Show that this PR is equal to that. All right, so on that note, let me just put it over here. Good. Show that PR is equal to that. So where is PR? PR there is facing this angle, and if we can figure out this angle, we know that this one on its own, this one, we solved this one, that it is what? It is beta minus alpha, and that means this angle as a whole and this alpha, they are canceling each other, which means this angle is just beta. Good. Now what are we having? We have PR divided by this angle that is facing PR, which is beta, which is gonna be sine beta, is equal to what else that we have? We also have this angle, which is angle P. Angle P wethu simfumene engu-90 minus alpha. Angle P simfumene 90 minus alpha. So we are going to say it's going to be this side divided by sine of that angle. So which is going to be TR divided by sine of angle P was 90 minus alpha, which is 90 minus alpha. Good. Now let's continue. We have PR, which is equal to TR times sine beta, then divided by what is sine 90 minus alpha? Is the same as cos alpha. Good. Now let's continue with PR, which is equal to, in the place of RT of TR, we know that our TR was given by d cos beta sine alpha. D, which is in the place of this, we put d cos beta divided by sine alpha, which is, yes, of course, this is what we are substituting there in the place of TR, then times sine beta, then divided by this cos alpha, which is cos alpha. Yes, so it needs your algebra now to remember that this cos is just going to be dividing there, of course, because we are going to multiply by just 1 over cos alpha, so it's going to go straight to the denominator still. So which means we are going to have d cos beta times sine beta divided by sine alpha times cos alpha. So this is what we have, and we did prove that, because you can see that this is totally the same as what we have found. So this is what we have. Do we have another thing? Yeah, I think we are done for that one. Let's come to question number 9. Question number 9, it says, complete the statement. The angle at the center, yes, of course, it has to be the center. The angular center is equal to 2 times the angular circumference of the circle. So we just had to write center there. And once ubuzwe le theorem, they are going to use it in the next questions. It's not a coincidence. They have to use it. The diagram that follows has to use the theorem that you have filled, or you have answered already. Now, coming to 9.2, see the diagram below. O is the center of the circle with point A, B, and C on the circumference of the circle. Good. Then BAC, which is this angle, is equal to x, and OBC is equal to x over 3. So determine with reasons the value of x. With reasons the value of x, we need to now to whatever statement that we write, we need to give the reason for that. So now, but at the end of the day, we know that BOC, which is this angle, is going to be twice that angle. So we know that BOC is 2 times x, which is that the angle at center is 2 times the angle at circumference. So this is what we have for now. That makes us to have 2x here. But at the end of the day, you also know that this angle is x over 3 reason, which means we have OCB is also equal to x over 3 reason. These are the angles opposite equal radii, because this side is equal to that side, because these are the radii. These are radii of the circle. Right. Now, you can see that we have everything in this triangle that you can just add them and add up to 180. So that makes 2x plus 3 plus x over 3 plus another x over 3, which is equal to 180, which is sum of angles in a triangle. That makes it to have 2x plus 2x over 3, which is equal to 180. Then we can just multiply by 3 throughout, which is gonna be 6. 6, yeah, it's gonna be 6x, then plus 2x, which is equal to 180. Then therefore we have 8x is equal to 8x. We multiplied by 3 throughout. That makes us to have 180 times 3. That gives us 540. Yes, this is 540. 540. Then even here we have 540. Sorry, 540. Then our x becomes divided by 8. Then we get 67 divided 67,5. So this is x 67,5. We figured out the value of x, which is 67,5. So we wrote everything with reasons. This is what was required. Moving to the next question. The next question says, in the diagram below, O is the center of the circle passing through A, B, C, and M. K is the center of the circle, not drawn, passing through point A, B, and C. We probably have a circle that is abnormal like that, but nonetheless, it's not drawn to scale. That such that we have what ABC of the what which are passing through the point A, B, and C of a triangle ABC. Yes, of a triangle ABC, such that K lies on the radius of OB. So yes, this K is on the radius of OB. Then what else that is given? We are given that A1 is equal to 30 degrees. A1 is equal to 30 degrees. Then OB bisects this angle. Bisect angle ABC, which means it bisects this angle, which means if this one is x, this one is also x. This is what is being given as bisect. Now, let's come to the first question. The first question says, determine the size of B1. The size of B1, which is this angle over there, we just need to supply reasons for our answers so that we get all these 5 marks. But we need to know that BOC is the same as 2 times A1. This is the angle at center. This is the angle at center theorem. So that makes it to be equal to now 30 times 2, which is going to be 60 degrees. Which is this angle is equal to 60 degrees. And we also know that B2 is equal to this angle. So B2 is equal to angle OCB. Reason, these are the angles opposite equal radi. Okay, so if that is the case, we also know that B2 is equal to 60 degrees. And also because these are sum of angles in a triangle. Now, if that is the case, since B1 is equal to B2, then it was from this information that OB bisect triangle angle ABC. So that is why we know that B1 is equal to B2. So on that note, B1 now is also equal to 60 degrees. So we did solve. Done. 5 marks, we got it. Now coming to the next question. The next question says prove that M, which is this angle, is 2 times A1. For this one, we just need to remember that in this cycle, we have a cyclic quadrilateral like that. This is a cyclic quadrilateral, and the cyclic quadrilateral the opposite angles are supplementary. So if we have 60 here and we also have 60 here, and that makes this to be just 120, and of course this has to be 60 degrees to make 180. But at the end of the day, we need to show what you call the the calculations for that remarks. So what are we having? We have angle ABC is equal to 120 degrees. The reason we did the proof. Then now we have angle M is equal to 60 degrees. These are the opposite angles of a cyclic quadrilateral. Therefore, M is equal to 2 times A, since A1 is equal to 30 degrees. So we are done for 9.3.2, just like that. Coming to the next question. The next question, which is question number 10. Question number 10, in the diagram below, P, Q, R are points on the circle. P, Q, R are points on the circle where YR bisects PRQ. YR bisects PRQ. Okay, that makes this angle to be equal to that angle if YR will bisect that angle. Now, what else that we have? We have PQ is produced to meet SR at S such that SR is equal to SY, which means this SR is equal to SY, which means these sides are equal to each other. So if these sides are equal to each other, you'll just remember that these angles has to be equal to each other as well. Now, if this is just what we have for now. Let's come to the question. The question says, prove that SR is a tangent to a circle at R. Kutwa SR, which is this line, is a tangent to this circle at R. So that this is a tangent. This information was not given for a tangent. We just need to prove that this SR is a tangent to a circle. But at the end of the day, we need to know, when we are proving the tangent, what is it that we need to know? So here, for this angle to be, for this line to be tangent of the circle, this R3 has to be equal to this angle P. We just need to prove that R3 is equal to P, because once now uthethwa a tangent, just remember Chord theorem or its converse. Now, how R3 equal to P? This is how, this is what we need to figure it out. Now, the idea is to remember that in the information that is given there, we have Y2, which is this angle, which is equal to this whole angle. Okay, now which is Y2 is equal to R2 plus R3, and it is given by that these are the angles opposite equal sides. Okay, now if that is the case, we also know that this Y2, this angle, is the exterior angle of triangle PRY. So if that is the case, the exterior angle is equal to the sum of opposite interior angles. So that makes it to be Y2 also equal to R1 plus angle P. So these are the opposite interior angles of triangle PRY. So on that note, we can say exterior angle of a triangle. Now, it is given from the statement that R1 is equal to R2. It is given by the use of this information that YR bisects that PRQ. Now, if that is the case, in the place of R1, I can put R2 because this angle is equal to this angle. Okay, so therefore R2 is equal to Y2 is equal to R2 plus P. So this is what we have. So on that note, we know that this is Y2 and this one is also Y2. Okay, so which means this angle, this side, these equations are equal to each other. So we can just say this one, which is R2 plus R3, is equal to, because Y2 is equal to Y2, which means this one is equal to this one. So it's equal to this one, which is R2 plus P. Okay, so if this side is equal to this side and R2 is equal to R2, then R3 must be equal to P. So therefore now R3 has to be equal to P. So therefore, because this is what we have to prove, that this R3 is equal to P. But how? This is our proof that now this R3 is now equal to P. So therefore RS is a tangent to a circle at R. Why is it a tangent? Because it's there's a converse of tan chord that holds. Okay, now moving to the next question. The next question says, prove that QR is a tangent to the circle passing through Q, X, and P. So we are proving that QR, where is QR? Let me just clear up something up. That QR is a tangent to a circle that passes through Q, X, and P. So that means we have this circle that passes through that, and you have to prove that this angle over here is equal to that angle. This is just what you need to prove. So on that note, we just know that this angle, which is Q2, is equal to R3. Reason, these are the alternate angles, because these lines are parallel to each other. RS or SR is parallel to XQ. That is why alternate angles are equal to each other. But R3 was proven to be equal to P, then therefore Q2, which is equal to R3, is also equal to P. We just had to prove that this angle between this line and this chord is equal to that angle. So if Q2 now is equal to P, then therefore RQ is a tangent. Therefore QR is a tangent to that circle. tangent to that circle, sorry, to that circle, because the angle opposite this angle is equal to that angle there. Now let's go to the next one. For this one, I think I must come later, but at the end of the day, the idea here, we are to prove that AD over BD is equal to AE over EC. The idea is to construct perpendicular height, which is this one. Let's say this one, it's perpendicular to that base, and we construct this line. Now on that note, we just need to find the ratio of this triangle and this triangle. So after finding this ratio, then we go to another side. So on that note, since this height, we can just call it the height, and it has to be perpendicular. This height is perpendicular to this base, and we are going to use this side. Now we are having construct height to be perpendicular to AD, and construct ubani line EB. Good. Now, which means now we are calculating the area, the ratios of these areas. So we are having area of triangle ADE divided by area of triangle this EDB. So the idea is to know that, okay, the area of ADE, if this is the base, this must be a base, ladies and gentlemen, and which is going to be half base of a base, which is AD, times perpendicular height. This is the height of this triangle, times what? Times perpendicular height, then divided by the area of this triangle. Remember, the area of this triangle has the height which is outside. Can you see that? Which means these two triangles, they share the same height. Wow, I like that. So we have 1 over 2. Then the base of it is going to be this one, because this height has to be perpendicular to its base. So which means the base is DB, then times the very same height. So we can just simplify these kind of things, cancel what can cancel, then we're left with AD over DB. Wow, lovely. So coming to the next one, where we are going to construct another perpendicular line, then perpendicular to this base, then therefore also constructing this one, so that we have this triangle over there, this triangle. Good. Now what are we having? We have area of triangle AED divided by the area of triangle ECD. So we know that it's going to be half, our base is going to be AE now, AE times this height, you can just give it its name, that it's K, then divided by another half, then this is going to be another base, which is EC times K. Then therefore, if we just simplify everything else, that you're going to have AE divided by EC or CE. So this is what we have. We also remember that the area of this triangle and the area of this triangle, they are equal to each other, because these are the triangles that are between parallel lines.
and these are triangles that are between parallel lines and they share the same base, and that is gonna be their base. Okay, good. So now, but area of triangle, but area of triangle DEC is equal to the area of triangle DEB, because these are the angles, these are the same triangles with the same base, same height, or these are the triangles that are between parallel lines. You can just say that way. So it gives us the clear image now that this one is equal to that one. So we are now having AD divided by DB is equal to AE divided by CE. It's very important to know how to prove your theorems. Then therefore, this is what we have done. Coming to the next question. The next question, which is question number this, of course, then we are required to, in the diagram below, PO, which is PO is parallel to OLM, such that the area of triangle POP, KOP, which is KOP, is equal to the area of this trapezium over there. Okay, now we are given now that okay, KYX is perpendicular to OP and LM at Y and X respectively. Good. Now let's come to number one. Number one says prove that triangle KOP is similar to triangle KLM. Now we have triangle KOP is similar to triangle KRM. So these are the triangles that we are comparing. But at the end of the day, we need to introduce the triangles that we're talking about in triangle KOP and triangle KRM. What do you notice? You notice that angle K is common, because this triangle, both of them, they have the very same angle. Then coming to the next thing, we have O, which is this angle, is equal to that one. O1 is equal to angle L. You can say these are corresponding angles. Angles are equal because OP is parallel to LM. Now we talk about the last one, which is P1 is equal to angle M. You can just say 30 angles of a triangle, or you can repeat the very same thing because these angles are also corresponding to each other. Now you can now say therefore triangle KOP is similar to triangle KLM, and the reason is all corresponding angles are equal to each other. Now let's come to the second question. The second question says what? Prove that KY divided by KX is equal to OP divided by LM. Now we are having what are we having? We have our information there that says triangle KOP is similar to triangle KRM. Now we need to take some corollaries so that we prove this information. We know that KO KO over KL is equal to KP over KM is also equal to OP over LM. Okay, so we have these corollaries because of similar triangles. Now, what are we having? We can go back to our proof that we are proving that this and that. So we need now to take this one into consideration, that we are having OP over LM, which is equal to, let's take what? Let's take KO. Let's take KO is equal to, let's rub this one for now. I don't have a reason for now. Let's just take KO divided by KL. So let's just take these ones and equate them to each other. Now, after that, let us not destroy this one, but let's just take this one and find out how this can be equal to this side over there. Now, we have KOP over LM is equal to what? Where are we? Where are we here? We have KO over KL. It is also equal to KY over KX. This is what we have. So it is equal to KY over KX. And you can see that we went to our diagram using proportionality. So you can just say proportionality theorem. So we have done our proof. Now let's come to the last test question. Let me just take this one out for now. Let me just take this one out for now. When this is just it, and then what are we having? We are proving that KO over KL is equal to 1 over root 3. Now, for this one, you will remember that there is an area that was given, the area of KOP, the area of triangle KOP, which is this one, that they said it is equal to the area of triangle of a quadrilateral OLMP, which is this quadrilateral. So that means if the areas are equal to each other, if the area of this is x and the area of this is x, that means the area of the entire shape is equal to 2x. That's what it means. So that means now the area of triangle KLM, which is the biggest triangle, is equal to 2 times the area of what? The area of the 2 times the area of triangle KOP. So this is what we have. Now, the area of triangle KLM, we can just say this is the base and this is going to be the height. So which means now we have half, our base is LM times our height is KX. Then it is equal to 2 times the area of KOP. This is KOP. Then this is going to be the base and this is going to be the height. And yeah, this is going to be the base and this is going to be the height. So which means now we have half, the base is OP times the height is ky, which is ky. Okay, now let's try to simplify things up. Let's have 1 over 2 lm times kx is equal to, if you multiply this 2 by this half, then you will just get 1, which means now we'll be left with just op times ky. Okay, now we will remember that. Let's just have what? Let's just divide. Let's just divide by, let's just multiply by kx and ky. This side, let's divide by lm times ky. Then this side, let's divide by the very same thing, lm times ky. Then so that this lm cancel that one, and this ky cancel that one, then we will end up having just 1 over 2, then kx over ky divided by op over lm. Okay, now I really want us to think twice, just to have something that has to do with ko and kl. Ko and kl, we know that kx, which is kx over ky, is the same as kl over ko. Okay, so this is the proportionality theorem that tells us. Let me repeat. We are having kx. This is what we have. We are having kx, which is the longest side, divided by ky. This is what we have over there. It is equal to the other longest side divided by ko. So which means in the place of this, I can write this other ratio. So that means we are having 1 over 2, then times we have kl divided by ko. Okay, then therefore this is equal to, no, yeah, this is equal to op divided by lm. But at the end of the day, I can just take this 2, which is dividing this side, and to multiply that side. But nonetheless, let me just for now leave it this way. Then what are we having? Let's have OP and LM in our diagram. OP and LM. OP over LM. Let's go to OP over LM. OP over LM, which is the shortest side, divided by the longest side. It is equal to, I want us to have KO always and KL, because in our proof we have KO and KL. So that is why we are going to say, since we are having OP over LM, we are going to say now OP over LM is equal to the shortest side divided by the longest side, which is KO over KL. So allow me now to say we have 1 over 2, then times KL over KO, then is equal to, remember we said KO over KL, which is in the place of this, we have KO over KL. Okay, now we can now use, because at least we have all this in one. Now cross multiplication, we're going to be having KL squared, yeah, then this side is equal to, we can just also take this 2, which is going to be 2KO squared. Okay, now what are we having? We can just divide by KL both sides. So when you divide by KL squared dividing by KL squared, then you will see that this side you'll be having 1, then this side you'll be having just 2 KO squared divided by KL squared. Then this 2, if we can just divide by 2 both sides, you will see that this side you'll be having 1 over 2, then is equal to KO squared divided by KL squared. So on that note, we can just square root both sides so that we get 1 over root 2 is equal to KO divided by KL. So that means now we did prove this thing. Now it is not that easy, but at the end of the day we just need to find a way to go around the diagram and apply your proportionality wisely and know how do we use these corollaries using the diagram and also using similar triangles. Now I also have another way which may be longer than this one, which is manually gonna be dealing with this trapezium and this triangle. So on that note, let me just wrap this one, but you know that you can always come back whenever you want to check what you're missing. Then let me just take you to this one, which is the last thing to do, because at the end of the day, questions like these, we just need to have a skill and many ways of approaching it so that we get used to and be familiar with most of the things. Now, what are we having here? We are having the triangles, the area of this triangle. The area of this triangle, which is 1 over 2, which is times what times OP times what? Yeah, let me just use times OP times KY, which is the base times height. Good. It is equal to the area of this trapezium. I can call it trapezium because there is one pair of opposite sides that are parallel to each other, and the area of trapezium is 1 over 2 times sum of opposite side, which is OP and LM now. So sum of opposite sides, then times the what? The perpendicular height, which is what now? Which is YX. Now, on that note, you can just divide by half both sides so that you have cancel each other. Then you end up having this kind of situation. Then you have OP. Then, yes, you have OP plus LM. Then times YX. Now, on that note, we can just multiply. We can just let's just divide by what? Let's just first divide by, yeah, let's just divide by YX through both sides. Let's divide by YX both sides so that we have OP times KL divided by YX. YX is equal to OP plus LM. So this is what we have. Now, if we can just take this OP to the side, OP times LK over LX, yeah, then minus OP is equal to LM. Yeah, now what are we having? We have OP that we can just take it as a common factor, upper binomial. Then taking OP, we'll be having OKR over LX. Yes. over Lx. Yes, it's is it Lx? It's y, it's yx, then it's yx, sorry, then it's yx. Good. So this is what we have. Then we have -1. Remember, we just took out the common factor here. Then we are left with what? With KL over yx minus 1. Then this is equal to LM over LM. Yes, over LM. But at the end of the day, we can just divide by OP both sides so that we have this cancel this one. Then at the end of the day, we have KR over YX minus 1, which is equal to LM over OP. Good. Now, what we can do, we can always, let's just try to figure out, because at the end of the day, we want to take everything to KO and KL. So here, LM divided by OP. Where is LM? LM divided by OP is the same as KL divided by KO. Good. Now, in the place, so we are having KL over XY. Then we can take this one to this side and this one to the other side, so that we which means KLM is gonna be KL, gonna be having KL here divided by KO. Yes, KL divided by KO then is equal to just 1. Okay, now what are we gonna be having? We're gonna have, what are we having here? KL over yx, KL, KL over xy. Is it KL? Yes, KL over yx, KL over yx. Okay, what I have, KL is, okay, yx over yx, KL. All right, all right, what are we having? It's no yx, it's no yx there, it's no KL there, it's no KL there. Okay, so it's been no yx, no yx, no yx, no yx, no yx. So on that note, wait, let's just work it out. KL is the same as, okay, what are we having? We have KL times KO divided by, okay, minus what? Yx times KL. Now what are we having? We have divided by Yx times KO. Yes, then this is equal to 1. So on that note, we can always have KL times KO, then minus Yx, then times KL is equal to, then this one can just move to that side. So we have Yx times KO. Okay, now on that note, what are we having? We have, we can take this one to this side. We can take this one to the side. So what are we having? We have KL times KO minus YX times LK, then minus YX times KO is equal to 0. Then what are we doing? What we do, we can always take out a common factor to these ones, taking out common factor in KO, then KO is taken out, then we are left with what? KL minus what? KL minus, okay, on that note, let me just not do that one. Let me just say KL times KO. Then to these ones, let me just remove common factor and go YX, then minus YX into, then we have KL, then minus KO, then is equal to 0. Then on that note, KL minus KO, KL minus KO, KL minus KO is the same as LO, is the same as LO, but nonetheless, if we can just yeah, what are we having here? We have KO. We can always divide, if we can divide by all right, I figured it out that this is the area of this triangle. Remember, the area of this triangle is OP times KY, not KL. So it's this one, this is supposed to be Y, this is supposed to be Y, this is supposed to be Y, and this is supposed to be Y, this is supposed to be Y. It wouldn't be long if I didn't make this mistake. This is supposed to be Y, and this also supposed to be Y, and I think this one is fine. Then we have this supposed to be, yeah, this supposed to be Y. That makes it yeah, but from here I can just make it clear for this one, because at the end of the day it will be just shorter, and if Bendy understand it, this one. So KY, so KY over YX, which is KY over YX, is the same as KO over OL. So which means here we can say it's just KO over OL, okanye LO okanye OL, then minus KL over KO, then this is equal to 1. So on that note, we can just say we have KO squared minus, then OL, then minus times KL, then all divided by, you can just say time is equal to OL times KO anyway. Then therefore, what do? We're gonna say, yeah, in the place of KO we have KO squared, then minus, then OL can be changed. OL is equal to KL minus this one, so which means OL is equal to this whole thing minus this portion, which means KL minus KO, which means here in the place of OL I can just say KL, then into OL KL minus KO. Then therefore this one we can just take it this side. This side also we have ubani KO, which is the same. OL is what? Is KL minus KO. So this is what we have. This is equal to 0. Then we have KO squared, which is KO squared then minus, then KL times KL is KL squared. Good. Then we have KL nalena kube ngubani, kube ngu-positive KL times KO. Well, then sibuye sizephi, sithi minus this times that, ibe ngubani, ibe ngu-negative KO times KL. Then this times that one is gonna be positive KO squared. Then this is equal to 0. Now on that note, we can see that KO squared plus KO squared give us what? 2KO squared. Then now we also have negative KL squared. Then KL times that and this times that and this, you can see that these are like terms and their additive inverse, they just give us 0. Then therefore the answer becomes just 0 on that side. Then on that note, we can just always say we have 2KO squared is equal to KL squared, just taking this one to the other side so that it changes the sign. Now let's go back and check. Now KO is KO divided by KL, so which means now let's just divide by KL squared divided by KL squared. Then you will be left with what? You'll be left with this, cancel that one, then we'll be having 2KO squared divided by KL squared is equal to 1. Then therefore these two can divide both sides, then you'll be having KO squared divided by KL squared is equal to 1 over 2. Then you can square both sides now to have KO over KL is equal to just 1 over root 2. So this is the proof of it, and sorry for the mistake that I've just made there, otherwise it wouldn't be just long, but it would be long, but not this long. Nonetheless, this was paper 2, June examination 2022. This is the memorandum of it, and I am willing to give you more of these kind of things, but through your support I'm going to make it possible for us to continue with this, because at the end of the day I'm trying to make it interesting and easy to be followed, as people have the negative attitude towards paper 2. So on that note, I will try by all means to take as many question papers and do as I did, and I believe that with you I'm going to move forward. So thank you guys. Mr. Damboza, which is your friend on this channel, is going to keep you updated in anything that come that is new and everything else. So I'm trying by all means to cater your needs and everything else. So please ask questions and keep yourself busy, and of course the channel is also yours. With that being said, thank you guys, and see you right in the next video. And I'm preparing to do videos of this kind and in future time, but for your support I can always move forward. Thank you guys, see you right in the next video.